Alright, hello there first year design students. Today we are going to show you how to connect everything to your robot. Connect all the parts together properly to ensure that nothing lights on fire or explodes and all your sensors work properly. So, we're going to start out by distributing power over your robot. So you're going to need a battery, which is in your kit, a fuse block, which is also in your kit, one of these male-end battery wires that matches the battery, and then two of these ring connectors, which I've already connected for convenience sake. So you will take this male-end wire, connect a ring terminal to both of these, and bolt them as shown on the fuse block. So your red 12-volt line will go to the fuse block distributor, and your black lead line will go to this top corner where all your grounds will be connected. And then once you have this all rigged up, all you simply do is connect the battery the proper way. Sometimes they're a little finicky, so you gotta jiggle it around, but then you have a solid connection, and this fuse block has 12-volt power to it now. Okay, so now that you have your power block set up, we are going to connect the Arduino to the power block. And what you're going to need is your Arduino, of course. This barrel, it's called a barrel connector. It should have two lines leading out of the back of it. And then two of these, they're 1/4-inch spade connectors. And we have bajillions of these, so if you need them, just ask someone. And you will also need a 3-amp fuse, which looks like this. It's purple. It has a 3 on the top of it. Okay, and so the first thing you should do is take your barrel connector and connect the red wire to any slot on this fuse block, just like that. And they slide on, and they should have a good connection. If not, just kind of pinch the terminal a little bit, and hopefully it gets a better connection. Obviously, put the black with black on the top corner here, and then you're going to want to put your 3-amp fuse in the slot, and this protects your Arduino from oversurging or anything like that, and blows the fuse instead of blowing up a $40 Arduino. And then once you've done that, just take your Arduino, plug it in, and you should have a little green light on your Arduino like that. If you have, you are the master of robots. Congrats. This is pretty advanced stuff. Okay, so now we're going to be connecting a DC motor to our previous setup from the other steps. So new things you'll need: a DC motor. You'll need the VEX motor controller, which should be in a little tiny red and white box in your kit, and 3 prototyping wires. This one's for signal. It'll need to have a female end on one side and the male end on the other. And then 2 power wires, both of which have a female end pin on one side and the 1/4-inch spade connectors on the other. So, once you have all those things gathered and put together, we are going to take our 2 wires from here, and we're going to connect the red to a new slot on the fuse block, and take the black wire and connect it to any spot on the grounding plate. And then once you've done that, you will take your VEX motor controller, and you'll see there's a white wire, a orange wire, and a black wire. Now it's orange on this side just because it's red on the other side, so orange is your power wire. So you will connect the red wire to the middle pin for the orange, and the black wire to the black wire on the controller. Oops. Okay. So that's that. And you'll also want to put a 4-amp fuse. It's pink. It's got a 4 on it. In the correct slot, so to match up with your lead wire. And once you've done that, take your signal wire, which has the male and female ends. You're going to take the female end and put it in the white slot of your VEX controller, and then this will go in a number of different places depending on what kind of motor you're using. If you're using an encoded motor, it's going to go on digital pin 5 or 6, depending on what you want, and if it's not encoded, you can put it on pin 7 or 8. So I'm just going to go ahead and strap mine into pin 5. And so now our VEX is properly set up. Yeah, here's a better shot. See, it's in pin 5, I think. Yes? Yes. Okay. So the VEX is now connected, and all we need to do is connect the motor to the VEX controller. So you will take your leads from the motor, and I do not have pins connected to this, but you would just connect the ends of prototyping wire like these to the leads from your motor, and then connect them to the right color in the VEX, and then you'd have a working motor. Okay, so now we are going to set up a servo motor, which is this, and these are wonderful. They rotate 180 degrees, and you can put in a degree input for what degree you want it to be at. They're just a nice change up from a DC motor. So what you'll need is a 5 volt regulator. This steps down 12 volts to 5 volts. You'll need a breadboard, which you got in your kit, and I'll show you how to use that. A servo, and then some various prototyping wire. I have already set mine up, but for the servo you'll need 3 male-to-male wires. They have male ends on either side. Any color you choose is fine, but just know that you'll need one for power, ground, and signal. And then for the breadboard, I have 2 wires that have the crimp terminals on one end and female ends on the other, and then I've got one that has the 1/4 inch terminal on one end and a male pin on the other, and then I have a simple male to female red wire. So let's go ahead and set that up. So first thing you'll need is the red and black wire, the short ones, and so this will connect to the fuse block here and here, and again you're using a 4-amp fuse. So those will connect like this, and then to this you will connect, and this is very important, so pay attention. You're going to have the 5 volt regulator facing you, so not its back, but with the have it facing you with the plate on the back. And so the 12 volt wire supply will go on this pin if it would attach properly. There we go. The 12 volt ground will go in the middle like that. So you need to hook it up this way because these two are the inputs, and then you will have 5 volt that outputs from the last pin. Another very important note about this is all of the heat, or I guess the 7 volts that are being done away with, all dissipate as heat. So as you can imagine, this gets really hot, like 1,000 million degrees hot. So I would bolt this to your robot frame so you have a sort of heat sink, otherwise you'll probably burn yourself. So very important to do that. And then so next we will take the red wire with the male and female ends, connect the female end to the regulator, and then connect this to really anywhere on your breadboard. It doesn't really matter. I'm just going to go ahead and connect it into this slot like that, and then take your other wire that looks like this to any other slot in your breadboard like so, and then this end grounds again to the fuse block like that. Okay, so now that we have this all set up, let me tell you a little bit more about the breadboard. Each row of 5 like this are all connected, so you can use these next 4 slots for any 5 volt supply that your robot uses. So a servo, for instance, can connect here. Any of your sensors will connect here too. So you're going to need a lot of slots. So what I would suggest is jumping with any kind of jumper wire. I just have this little fancy one here, but you can use prototyping wire or whatever you want, and jump this to another row like so. So now I have all of these slots that can use 5 volts, and I would do the same thing for the ground, but I don't have another one of those. So, but you get the idea. And so now we will connect our servo to this to give it 5 volt supply. So take your red wire, plug it into anywhere in this row, plug the other end into the red slot, which is the middle one on your servo. Do the same thing with the black wire, connect it to the ground, and then connect it to the appropriate slot on your servo, which is this one. And then all that's left is signal, which goes in the last slot in your servo. And this end will go to your Arduino, and it can go in either pins 9 or 10. Those are the pins that drive servos. So I cannot really see very well. There we go. And I guess you just heard it turn on, but now it has power, and I cannot turn it anymore because it is stuck in place. So that means we successfully wired it. Good job, team. Alright, so now that we have the breadboard set up, we are going to connect our first sensor, and this one is a ping sensor, just using this one for an example. It tells you how far away in centimeters you are from an object, say, in front of your robot or wherever you mount it. So very handy. So we're going to connect this up to the 5-volt supply on the breadboard. So what I have is 2 power wires, one side female, one side male, and we will go ahead and connect these up. So connect your male end anywhere on your power row on your breadboard, and then if you look closely on the sensor, it tells you exactly where things go. So oh, I have this flipped upside down. My bad. So the top one is G and D, which stands for ground, so your black wire will go there. The middle one is 5 volts, so your red wire will go there, and then SIG is signal, and your yellow wire will obviously go there. So I'm going to go ahead and take my red wire, plug it into the middle slot, and then I will connect my ground wire to the breadboard, and then to my sensor, and we should hopefully see maybe things light up, but not yet. And then I will take my signal wire and connect it here. If it would go on. There we go. And then this end goes in pin 13, specifically for this, digital pin 13 for this sensor. And the reason it's there is because that's how we coded the firmware. It needs a special function. So this ping sensor specifically goes in pin 13. Not all sensors have to do that. So that's how you set this sensor up. Yes. Okay, so all the other sensors will be shown where to plug them in the PowerPoint slide that will accompany this video. So refer to that if you're confused on where your sensors go. Okay, so this last section is going to cover encoded motors and how to connect them. You'll see the back of this motor has a little knob on the back, and this is the encoder that keeps track of how many revolutions the motor makes. And it has this bundle of wires with a harness that comes off the back of it. I'm going to show you how to hook this up so you can, use the encoder function on this motor. So, on the actual harness itself, we have a black, white, red, and brown wire. Now, the brown and white wires are both signal wires. We only need one of them. I can go into detail if you're really curious, but I'm not going to go into detail now. And obviously the black and red are the power, and this runs off 5 volts. So we are going to be using our breadboard again. So take your prototyping wire, both male ends, and connect it to your breadboard. And then this end goes into the red slot like that. And then take your ground wire, do the same thing, like this. And this goes, I guess, on the end here. And then pick your favorite color, white or brown, does not matter. This plugs in to here. Again, it doesn't matter. But what does matter is which pin you put this into. So 2 and 3 are the encoder pins. Now, make sure that if your motor is in pin 5, you plug this into pin 2. If your encoded motor is in pin 6, you need to plug it into pin 3. Again, keep the PowerPoint handy. It runs through all of this. So if you're ever confused, just refer back to that. But I'm going to go ahead and plug this into pin 2. And so once you've done that, this is all connected, and whenever your motor's running, it will keep track of how far it's gone for you.